Find the x value at which f is discontinuous and determine whether f is continuous from the right or from the left or neither. Let's get started. To find the x value at which f is discontinuous and determine whether f is continuous from the right or from the left or neither, this is a piecewise function, so it's defined into three pieces. And since each part is a polynomial, this piece is polynomial, this is a polynomial, this is a polynomial, they're all continuous on the open interval. So let's write this down. F is continuous on the open intervals, negative infinity to 0, that's the first piece, 1 plus x to the second, and from 0 to 7, that's the second piece, and 7 to infinity, that's the third one. The reason why, since it is a polynomial on each of these intervals. So they are continuous while they are in the open interval, each piece of them. Now we need to consider the endpoints, which is, as you could see from the graph, 0 and 7. That's what we need to worry about or discuss in detail. For at x equals 0, we need to approach it from the right and from the left. This is when you go from the left of it, and this is when you go from the right of 0. So we're going to consider those two pieces, the first two pieces. So, limit f of x as x approaches 0 from its left. That's the red one, the first piece, will equal to limit as x approaches 0 from the left of 1 plus x to the second. And we could plug in 0 here, which is 1 plus 0, and that will give me 1 plus 0, which is 1. Next, the limit of f of x as x approaches 0 from the right, that's the second line, that's this right here, that's approaching 0 from the right, being greater than 0, will give me limit x approaches 0 from the right of 7 minus x, and that is 7 minus 0, which is 7. Clearly, that implies that f is discontinuous at x equal 0. And since f of 0 itself, we could use 0 itself from the first one, because that's the equal sign right there. We have 1 plus 0, which is 1. That says, from what we have so far, that f is continuous from the left at x equals 0, because from the left it's 1, and at the point x equals 0 is also 1. That will give me a continuity from the left. Okay, so it's continuous at 0 from the left. let's discuss the number 7. For the number 7, we have the following. At x equals 7, limit f of x as x approaches 7 from the left. That's when x is less than or equal to 7, which is right here, the second line, equals limit of 7 minus x as x approaches 7 from the left, which is 7 minus 7, and that's 0. When you approach it from the right, you will be greater than 7, and that's the third line. Limit f of x as x approaches 7 from its right will be the limit of the function that we belong to, and that is x minus 7 to the second as x approaches 7 from the right. And that is 7 minus 7, 0, to the second, which is also 0. Now we have f of 7, that's when it equals to 7. So we belong to this right here, when x equals 7. So we'll use that, and that will give me also 0. Since they all agree, they have it 0 here, and 0 here, and 0 here. From the left it's 0, from the right it's 0, and at the same point, at the exact point 7 is also 0. We say that f is continuous at x equals 7. To summarize that, I have the graph for you, and here we go. So the graph shows that it's continuous at 7. At 7 it's continuous. The limit from the left is 7. The limit from the right, the limit from the left of 7 is 0. The limit from the right of 7 is 0, and f of 7 is 0. So it's continuous at x equals 7. However, at x equals 0, it's continuous only from the left, because as x approaches 0 from the left, it's 1, and f of 0 is 1. However, when you approach it from the right, it's not 1, it's 7. And that is the discontinuity and continuity from right and left at endpoints, as you could see. And that should do it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.